Hello everyone. In this video, we're going to be solving an exponential equation. We have 2 to the power 2x plus 5 to the power x equals 41 to the power x over 2. And we're going to be solving for x values. What else could we solve for, right? Now, this equation is pretty interesting because if you think about it, it has different bases and different exponents. Even though the exponents are related, kind of like multiples of each other or whatever, they are still not the same. Because if you had the same exponent, well, to a certain extent, that will be better, but we're gonna try to solve it anyways, okay? So in that sense, it kind of looks like a pretty non-standard equation, but we're gonna try to make it solvable, okay? So how do you approach these kinds of equations? If it's easy, you can try to guess and check. For example, if x is equal to, I don't know, 1/2 or 2 or 3, you can just plug it in and kind of look at the values and see if you can get a match. But one thing that kind of makes this problem interesting is the presence of x over 2. So that kind of tells you, okay, I'm going to raise 41 to the power 1/2 and then to the power x. Does that make sense? So in other words, you can look at this as 41 to the power 1/2 to the power x, because x over 2 is 1/2 times x. So you can kind of look at it as the square root of 41 to the power x. Or you can interpret it a little differently. You can say, okay, I'm going to first raise 41 to the power x and then raise it to the power 1/2, which is again the same thing. And this would just be the square root of 41 to the power x. But guess what? These two things are equivalent, right? Especially when x is a real number, right? So how do we use this information? Well, first of all, that change made the exponent x, which is good because 5 also has an exponent of x. Now, the only thing we need to take care of is 2 to the power 2x, whose exponent is 2x, not x. Can we fix that? Yes, very easily. Here's how we can do it. 2 to the power 2x can be written as 2 to the power 2 to the power x, but 2 to the second power is just 2 times 2, however you interpret it. There's also 2 plus 2, but in general, this is multiplication, which can be written as 4 to the power x. Nice. By doing this little bit of manipulation, we were able to change all exponents to x, which is a good thing, maybe. Let's find out. So now we have the following. We had 2 to the 2x plus 5 to the x equals 41 to the power x over 2. Remember? Now we replace 2 to the power 2x with 4 to the power x. And 5 to the x is going to stay the same. And 41 to the power x over 2, we're going to write it as square root of 41 to the power x. And you might be wondering, how does this make the problem easier? Well, it kind of does. So first of all, let me tell you, if x is equal to 0, obviously, you should always check for that. For example, suppose you had an equation like this, okay? Let me just make up an equation on the spot. Obviously, x equals 0 is a solution, right? I mean, if you didn't check it, you would miss it. And solving this equation is probably difficult. And I remember there was a problem, something like this, that used the intermediate value theorem. Anyway, something like that, because you could basically define a function like f of t equals t to the power x, which is kind of like a weird way to define it, because we're used to x being the variable and t is kind of like a constant, but it's the other way around, kind of like an exponential function. And this would mean f of 2 plus f of 3 equals f of 5 plus f of 7. And then you kind of use some intermediate value theorem, something, IVT stuff. Anyways, I can't remember exactly, but that was an Olympiad problem from a really nice book. If I can find the book, I'll let you know. I think it was something like Mathematical Olympiad Treasures or something similar. There are 2 books of that kind, and they're just amazing. If you're preparing for Olympiads, obviously, most of those problems are harder than what we do on this channel. Anyways, let's get back to this. Now, going back here, x equals 0 does not work. You can plug it in. 1 plus 1 does not equal 1, obviously. And what about x equals 1? If you replace x with 1, 4 plus 5 is 9. That's not equal to square root of 41, so x does not equal 1 either. But why do we do this check? Because these are trivial solutions. And obviously, a negative solution is not going to work because that's going to make things harder. Maybe, right? Did you test it? I mean, think about it. Like if x equals -1, it's not going to work, so on and so forth. But the next value, if you're dealing with positive values, and you can kind of show that negative values are going to make it worse, you can basically do the following. How about the next value, x equals 2, right? Okay. If you try it, we're going to realize, okay, 4 squared plus 5 squared is 16 plus 25, and that's equal to 41. And square root of 41 to the second power is 41. So they're equal. Nice. We got a match finally, right? Well, this means x equals 2 is a solution. But we could also find it differently. So instead of going to x world, you could change it everything to x over 2 world. Like you can write it as 4 to the power x over 2, right? Because that is that correct? I don't think so. That should probably be 16, right? 16 to the power x over 2 plus 5 squared is 25 to the power x over 2, and then 41 to the power x over 2. This is definitely better because now you can hopefully see that, 16 plus 25 is 41, so this should be 1. Great. X over 2 equals 1 indicates x equals 2 is a solution. But the million-dollar question then is that the only solution? So here's how we can proceed. I think this would probably be the safest path. Let's go ahead and set x over 2 equal to, I don't know, y, t. Let's just go with t this time. And then this will become 16 to the t plus 25 to the t equals 41 to the t. And we know that t equals 1 is a solution, which implies that x is equal to 2, right? Great. Now, this equation is actually pretty easy to handle. Here's what we're going to do. Usually with these kinds of equations, if you have something like a to the t plus b to the t equals c to the t, where all the exponents are equal, you divide by the largest base. What do I mean by that? Divide everything by 25 to the power t. And I'll show you a really cool thing, okay? This will become 1, and this will become... Actually, it wasn't the greatest. I don't know why I thought it was 25. It's supposed to be 41. Okay, never mind. Let's back up a little bit. We're supposed to divide by 41 to the t. This is going to be 25 to the t over 41 to the t. And around the right-hand side, we're going to have 1. Okay, cool. Now, here's what we're going to do. We're going to write this as 16 over 41 to the power t and 25 over 41 to the power t, because we can take the t out, equals 1. Now, remember what we said, t equals 1 is a solution, so we know that. And it's also verified one more time by 16 over 41 plus 25 over 41 equals 41 over 41, which is 1. So yes, t equals 1 is a solution, but guess what? It's the only solution. Why? Because if t is greater than 1, imagine you're raising 16 over 41, which is a fraction less than 1, raising to higher powers like 2, 3, 4, 5, the number is going to get smaller. You think about 1/2. Square it, cube it, fourth power it, nth power it, it's going to get smaller and smaller. So in this case, 16 over 41 to the power t is going to be less than 16 over 41. And if you do the same thing for the other number, it's also going to be less than the base because the number is going to get smaller. And when you add these two things, our expression, which was supposed to equal 1, is actually going to be less than 1, which means there's no solution for t values that are greater than 1. T is less than 1 is going to give you something similar. Therefore, t equals 1 is the only solution. But you can also argue a little differently and say, this is a decreasing function, that's a decreasing function, this is constant, so a decreasing function can only intersect the horizontal line at one point. That happens to be t equals 1, which means x equals 2 is the only solution. What was the equation? 2 to the power 2x plus 5 to the x equals 41 to the power x over 2. And this normally brings us to the end of this video. This is the graph of these two functions where they intersect at x equals 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.